Yes, today we are going to discuss about the most important lesson, that is instrumental methods and applications. So this particular important session or lesson is very helpful to us to know the entire structure of a given organic molecule. That is most important thing. Okay, so this entire lesson is very helpful to us to determine or to, yeah, just a minute. To know the entire molecule of the structure. Suppose if I give a small tablet to you, okay, if I give a small tablet to you, I am saying that please estimate or please calculate what are the important components which are present in the tablet. Actually, by observing the tablet, we cannot specify what are the ingredients which are present in the tablet. Is it right or not? Yes. So if you want to estimate what are the individual organic compounds which are present in the molecule, and how the molecular structure will be there in that particular organic compound, and if the organic compound is having any double bonds or triple bonds, how many number of double or triple bonds are present in that organic molecule, or if the organic compound is having any functional group, what are the functional groups which are present in the organic molecules. These are the important data which can be easily determined by using these instrumental methods as well as applications. This entire instrumental methods and applications can be simply called as spectroscopy. It is simply called as spectroscopy. You know that I have divided this entire spectroscopy into two words. Spectro means it is nothing but equals to color. Spectro means color, and it is nothing but equals to spectrum. Colored spectrum. Spectro is nothing but equals to spectrum. Scopy means a study. Scopy means study. So if you study any of the spectrums which is occurred or which is formed by any of the instruments, spectroscopy instruments, spectroscopy instruments, then such type of spectrum, such type of study of the spectrum is called as spectroscopy. So in this particular lesson, what you need to learn is studying of a particular spectrum. Sir, if I study a spectrum, what I can get? What type of data I can get? Just now I have discussed. If you study a particular spectrum, suppose if you got this particular spectrum like this, by studying of this particular spectrum, you will get a good knowledge about the entire organic molecule and the structure of the organic molecule, and whether the organic molecule is containing any double bonds or triple bonds or substituents or functional groups, whatever the data which is present in that organic molecule, that can be easily estimated by using this particular spectroscopy. I hope you understand. So why we need to learn the spectroscopy? So in future, as a future engineer, what you need to do is, once you learn this particular spectroscopy, what you can easily guess? Simply by observing this particular spectrum and by study of this particular spectrum, you can easily find out whatever the data which is present in the organic molecule, the entire data you can easily get by studying of this spectroscopy. Got it? I hope you understand why the spectroscopy has been studied in this engineering level. Okay, let us start the spectroscopy concept. If you want to learn the spectroscopy, must and should you need to know what is meant by an electromagnetic spectrum. This is most important for us. You need to know the electromagnetic spectrum. Electromagnetic, that means in this particular spectrum, electric field is there and magnetic field is there. So the combination of electric as well as magnetic fields will forms one spectrum that is called as electromagnetic spectrum. See here, you can easily understand this electromagnetic spectrum. Why? Because already you have studied the entire electromagnetic spectrum at your lower classes. See here, this is a particular wave, this is entire wave. See here. So if you observe the distance between the two waves, this is a wave, this is a wave, this is a crust of course, and the bottommost it is called as trough. You are very aware about this particular concept. It is crest as well as the bottommost of the wave is called as trough. So in between the two successive crests or in between the two successive troughs, that is called as lambda. The distance between the two successive crests or the distance between the two successive troughs is called as lambda wavelength. See here at the left hand side, I have ticked here. At the left hand side the wavelength is very less, but at the right hand side the wavelength is very high. That means in this electromagnetic spectrum we will have the entire radiations, electromagnetic radiations in a particular wavelength. So from left to right slowly the wavelength will be increased. Just observe at the bottom of this picture. See here I have written the gamma rays and of the X-rays and ultraviolet as well as visible and infrared, microwaves as well as radio waves. What is the meaning of this sequence of this gamma to radio waves? If you observe the gamma rays, the wavelength is very less. And if you observe the radio waves, the wavelength is very high. Once the wavelength is very high, what about its energy? If the radio waves wavelength is very high, then what about its energy? You know the relation between E as well as lambda. Anyone, can you say? What is the relation between E and lambda? Anyone? Be quick. Okay, I will tell you. E equals to H into C by lambda. E equals to Hc by lambda. It is the relation between energy as well as wavelength. So if the wavelength has been increased, what about the energy level? Anyone? If the lambda has been increased, what about the energy level? Both are inversely proportional. So if the lambda will be increased, the energy levels will be decreased. So for radio waves, the energy is very less, but for gamma rays, the energy is very high. Okay. So whenever you are moving from left to right, see at the middle portion of this electromagnetic radiation, there are two different types of electromagnetic radiation region is there. One is UV and visible. The combinedly we can say that it is UV visible region, and it is called as IR region. UV visible region and IR region. So these two are very important for us with respect to the spectroscopy. So one is, we have discussed that UV visible region, and the second one is IR region. So these two regions are in electromagnetic radiation, right? So in the electromagnetic radiation we will have these two types of regions, UV visible region and IR region. If you observe this UV visible region, what about its wavelength? See here, H means it is frequency, nanometer means it is wavelength. Okay, H means it is frequency. So the ultraviolet region normally is in between visible region is in between 400 to 700 nanometers. It is approximately, visible region is approximately in between 400 to 700 nanometers. See here, 4 into 10 power 14 Hz and 7 into 10 power 14 Hz. That means if you convert this frequency into nanometers, you will get 400 to 700 nanometers. That is in visible region. So more than that visible region you will get IR, and less than the visible region you will get ultraviolet. Okay, that's all. So if you take any of the organic molecule, I have taken, just now I have discussed that. Suppose if you take any of the organic compound, if you want to determine, if you want to estimate or determine what are the components, what is the molecular structure, and how many doubles or triple bonds are present, and what are the functional groups which are present. If you want to know all this particular data, you can follow or you can estimate either different types of spectroscopies, either different, how the spectrum will comes out from this organic compound. Suppose if I am taking one organic compound in a beaker, and you have to keep this entire beaker into a spectrophotometer. It is called as spectrophotometer. Simply by keeping this particular beaker into a spectrophotometer, this spectrophotometer is connected with a computer monitor. This spectrophotometer is connected to a computer monitor. So once you switch on this spectrophotometer, after some time this computer monitor will show some graph. Simply by studying this graph, you can easily find out what type of organic compound it was. That's all. It is very simple to estimate the entire organic compound by keeping this entire organic compound in a test tube, and you have to put this test tube into this spectrophotometer. Okay. But before we are keeping this entire one into the spectrophotometer, you have to dissolve this entire organic compound powder or liquid into a suitable solvent. So before you are adding that particular beaker or test tube into a spectrophotometer, you have to dissolve it into a suitable solvent. So once it was totally gets dissolved, you have to keep that entire cuvette or test tube into the spectrophotometer and switch on the spectrophotometer. It shows some graph. Just by taking that graph as a printout, by studying that printout, you will get a good knowledge about the entire organic molecule. This is all about the basic principle of the spectroscopy. Okay, sir, how the graph will comes out on the computer monitor? How the graph will comes out once you switch on the spectrophotometer? Very simple. Suppose if you keep the entire organic molecule into the spectrophotometer, when you switch on, what will happen? If you switch on, slowly the light will be passed. The light which will be passed through the instrument. It may be UV visible, or it may be IR, or it may be other electromagnetic radiation. So such type of electromagnetic radiation will be passing through our organic molecule liquid. So once the organic molecule, see here, consider that it is an organic molecule liquid through which the light is passing. This is an organic molecule liquid. So once the light is passing through the organic molecule liquid, what will happen? These liquid will absorb some amount of wavelength containing light, because the molecules are having a capacity to absorb the light. When we passing the light through the cuvette or through the beaker, what will happen? The entire molecules will absorb the light, and the remaining light only will comes out. It only will be transmitted. It only will be transmitted, but some amount of the light has been absorbed. That absorbed light is nothing but equals to absorbance. That is nothing but equals to absorbance. Some of the organic molecule will absorb more amount of light, but some of the organic molecules will absorb less amount of light. So whether more absorbance or less absorbance, that absorbed light will converts into a signal, and that signal will be formed as a graph on the screen of the computer. Got it or not? So once you switch on, how the graph will comes out on the computer screen? Because once you are switching on the spectrophotometer, one light will be passing with a particular wavelength. Every light is having their own wavelength, right? So with a suitable wavelength, with a particular wavelength, the light is travel, and the light is transported or transmitted through this particular solution. When it is transmitting through this particular solution, in that solution organic compound, the molecules will absorb the light, and basing on the absorbance, the particular absorbance will converts into a signal, and it will forms as a spectrum on the computer screen. So this is the main principle which is involved in a spectroscopy. This is most important one also. You have to know what is the principle which is involved in the spectroscopy. Sir, why once the absorbance is possible, how the absorbance will convert its signal and it will form a spectrum onto the computer screen? There is a small reason. Suppose if the absorbance is there by the organic molecules or atoms, what will happen? Once the organic molecules will absorb the light, what will happen? In the atoms or molecules, so many number of electrons are there, we know very well. Atoms or molecules are having so many number of electrons. But once the light has been absorbed by these electrons, electrons may have much more amount of energy. Once the electrons are having much more amount of energy, it will get excited. All the electrons will get excited. That excitation will be possible in three different types of ways. In sometimes only excitation is possible. In sometimes, just a minute. In sometimes only excitation is possible, but in sometimes what will happen? Along with excitation, some of the atoms will get vibrates. Some of the atoms will get vibrates. In sometimes only the electrons which are present in the atoms will get excited, but in sometimes basing on the intensity of the wavelength of the light, the atoms may get vibrates. But in sometimes what will happen? The atoms may get rotates. So there are three possibilities we have once you are passing the light through the organic molecule. In sometimes In sometimes what will happen? The light has been absorbed by the molecules. After absorption, the electrons may get excited. This is one possibility. In sometimes the atoms will get vibrates. In sometimes the atoms will totally gets rotates. Atom rotation means later we will explain which particle will rotate. Later I will explain. So there are three different types of possibilities we have once you are passing the light through the organic molecule: excitations, vibrations, and rotations. So if the excitation is possible only in, yeah, just a minute, this excitation is possible only in, yeah, tell me anyone, have any doubt? Okay, no problem. Suppose if the electron will gets excited, if the electrons will get excited, that excitations are possible only in which spectroscopy? Only in UV visible spectroscopy. So there are three different types of spectroscopies we have. One is UV visible, in which what will happen? All the electrons will get excited. All the electrons will get excited. But in IR spectroscopy, what will happen? The atoms will get vibrates. So by the vibrating of the atoms, the computer on the monitor, on the screen of the computer, you will have one spectrum. By studying the spectrum, you will have some more knowledge about the molecule. And the last one is NMR. The full form of NMR is nuclear magnetic resonance. Nuclear magnetic resonance spectroscopy. So this particular spectrum by this NMR spectroscopy will be formed by rotational, by rotation. So there are three possibilities we have. One is excitation of the electrons, second one is vibrations of the atoms, third one is rotation of the proton. Rotation of the proton. So basing on these three different types of techniques, different spectroscopies will be there. Sir, why different spectroscopies we need to consider? Means UV visible spectroscopy. In UV visible spectroscopy, we will not get the complete data about the molecule. We will get only a small amount of data, can be easily determined with the help of UV visible. And if you take the IR spectroscopy, whatever the data which has given by the UV visible spectroscopy cannot be determined in the IR spectroscopy. This will give us a different data of the organic molecule. Got it? And if you take NMR spectroscopy, NMR will not give the data of UV visible as well as IR spectroscopy which they have given. But NMR spectroscopy will give a different type of data of the particular organic molecule. So combinedly, or finally, if you combine all these three like UV visible or IR or NMR spectroscopy and mass beam spectroscopy, so many different types of spectroscopies we have. If you combine all the data of these spectroscopies, we will get the complete knowledge of the organic molecule. I hope you understand well, right? So what is the main advantage of this spectroscopy? Spectroscopy will give the complete data about the complete organic molecule. That's all. If you take any of the organic molecule, this spectroscopy will give the complete data. But how we will get the data? By studying that spectrum. So you have to know the study of the spectrum. That is most important. So without knowing the knowledge about the study of the spectrum, we can't get the data of the organic molecule. Even though you are having a spectrum on the computer screen, you will not get the data. You may not have a good knowledge about the data of the organic molecule, because you have to know, you have to study how to study that particular spectrum. You have to know how to study that particular spectrum. Otherwise, you will not get the data of the organic molecule. That's all. See here. This is an absorption radiation. See in this, it is a ground state. Once the electrons has been absorbed some amount of light, it will get excited. So this is electronic levels, excited state. See here, these are all excited states. All the excited states are maybe electronic excitations, or maybe vibrations, or maybe rotations, Got it? So the rotation levels energy is very high, whereas vibration level energy is somewhat less, whereas excitation of electrons is somewhat again less. Okay, so this is the entire absorption of a particular radiation. See, again I have discussed the same thing. It is a vibrational transition and it is a rotational transition. So in the vibrational transition, this will be excited, and in the rotational transition it will be excited like this. These are all just energy levels when we are passing the light, whether it is UV or IR or NMR light onto the particular organic molecule, these type of transitions are possible. Electronic excitation transitions or vibrational transitions or rotational transitions are the particular organic molecule will be possible. And see here, this is the spectrum which is coming out when we are passing the light through the organic molecule. So that spectrum is formed. In between what parameters, it is most important. That spectrum is plotted, that graph is plotted on the computer screen, is in between wavelength as well as absorbance. So percentage of absorbance or the absorbance and wavelength. So if you plot a graph in between the wavelength, which is to be taken on x-axis, and the absorbance, if you take it on y-axis, it will form a plot like this. It will plot a graph like this. So on x-axis you need to take the lambda, on y-axis you need to take the absorbance. Okay, so this is a particular spectrum, absorption spectrum. Actually there are two different type of spectrums, emission as well as absorption spectrum, but this spectrum is completely belongs to absorption spectrum. Got it? Because the organic molecule will absorb the light. Basing on the absorption, the electronic transitions or the vibrational transitions or the rotational transitions are possible. That's why it is called as absorption spectrum. Okay, so let us start the UV visible spectroscopy first. Later we will discuss IR as well as NMR spectroscopy. Okay, let us start the UV visible spectroscopy. How the UV visible spectroscopy will be there, and how the instrumentation technique will be there. So this is the instrumentation technique of UV visible spectroscopy. Just observe this entire components which are present in the spectrophotometer. See here, actually this is the instrument. This is the UV visible instrument, single beam or double beam instrument. It is UV visible instrument. It is, see, this is particular area in which only you need to keep this cuvette. So in this cuvette you need to take the organic molecule, and you have to place it in this cuvette. They have two different types of cuvettes we have. One is for blank and the second one is for sample. One is for blank, second one is for sample. Blank means it is for detection of a particular compound. You need to use a particular blank solution. Sample means it is our sample. Okay, and if you close it and if you switch on it and if you power on, automatically it shows some graph onto the screen, and it is to be connected with a computer. See here, on this computer screen you will get a particular graph. By studying this particular graph you will get a good knowledge about the organic molecule. That's all. Got it or not? This is the entire technique of UV, entire instrumentation technique of UV visible spectroscopy, in which what you need to do is, first of all you need to pass the light source. It is a light source. Through this light source, this entire light source is to be passing through this particular sample, but you have to adjust the wavelength. You have to adjust. Before we are passing the light through a sample, you need to adjust the wavelength. For UV visible, already I mentioned the wavelengths. For UV visible you have to adjust the wavelength in the particular spectrophotometer, and you have to pass the light. Then once the light is passing through the sample, automatically some amount of the light has been absorbed by this molecule, and the remaining light will be transmitted. That will be detected by a detector, and finally this wavelength or this particular light has been converted into this light signal to electrical signal. That means computer signal. That means in the output you will get the spectrum. This is the entire instrumentation of the UV visible spectroscopy. So this is having light source, wavelength selector, sample, detector, and finally processing unit. Computer and signal processing unit it is. Okay. So finally you will get an output. So by taking the printout of that output of the graph, by studying that particular graph you will get a good knowledge. That's all. Right. See here, in the UV visible spectroscopy, what will happen? This is most important one. If you take any of the organic molecule, please remember one important thing, that is this entire spectroscopy is only meant for organic compounds. Please remember that one. Okay, this is an organic molecule. If you take any of the organic molecules, if the organic molecules is having any sigma electrons or any pi electrons or any n electrons, n means non-bonding electrons, that means lone pairs. N is nothing but equals to lone pair. Lone pairs. With the lone pairs, there is no formation of any bond, only except coordinate covalent bond. There is no normal covalent bonds will be produced with the lone pair of electrons. Okay. So the organic molecules which are having n electrons, pi electrons, and sigma electrons, these electrons will absorb the UV radiation and undergoes transitions, and it will undergoes transition. So once the electrons, n electrons or pi electrons or sigma electrons, if they absorb the light, it will totally gets excited. It will totally gets excited. They will convert from ground state to excited state. This is the main principle involved in UV visible spectroscopy. Okay, sir, why the UV visible spectroscopy should be studied by us? Means this is the reason. This UV or visible spectrum is quite useful for the detection of conjugation. Anybody knows what is meant by conjugation? And carbonyl group also. So this UV visible spectroscopy will give the data about the conjugation and carbonyl group. What is meant by conjugation? Anyone? What is meant by conjugation? Anyone? No problem. Whether it is right or wrong, please tell me. No problem. What is meant by conjugation? Conjugation means what? Okay, no problem. I will tell you. Conjugation is nothing but equals to the alternating double bonds. Alternating double bonds is called as conjugation. So conjugation is nothing but equals to alternate double bond. Suppose if you take 1, 2, 3, 4, 5 carbons, I have taken one single bond, one double bond, one single bond, one double bond. That means there are alternating double bonds we have. So once if you take any of the organic compound in which alternating double bonds are present, then we can say that it is in conjugation. That organic molecule is in conjugation. Okay. This conjugation technique can be easily explained by this UV visible spectroscopy. And the carbonyl group. What is meant by carbonyl group? Anyone? What is meant by carbonyl group? Carbonyl group means if any organic compound is having this type of functional group, C double bond O is called as carbonyl group. So if any organic molecule is having this type of functional group, such data also will be given by this UV visible spectroscopy. So spectroscopy will give the data about the conjugation and the data about the carbonyl group in general. Okay, conjugation means alternating double bond. Carbonyl means the molecule should contain C double bond O functional group. That's all. Okay. So once the organic molecule will absorb the light, then what will happen? Electrons will get excited. By exciting the electrons from ground level to excited level, it shows some spectrum, absorption spectrum. It will give one absorption spectrum. By studying that absorption spectrum, you will get these two knowledges. You will get these two knowledge. Whether our given organic molecule is having any conjugation or not, that is one thing. And whether the organic molecule is having any carbonyl groups or not. These two are most important for us. Okay. So this type of data will be given by UV visible spectroscopy, whether it is having conjugation or not. Usha పాలు వచ్చేయి. Usha పాలు. So this alternating double bonds means conjugation, carbonyl groups. These two will be given by the data by UV visible spectroscopy. Okay. See here, just now I have discussed that the number of conjugated double bonds. Conjugate double bonds means already I mentioned you. How many number of alternating double bonds which are present in the organic molecule, that will be given by the electronics UV visible spectroscopy. And aromatic conjugation also. Aromatic conjugation means, suppose if you take this double single, double single, double single, it is also in conjugation, but it is an aromatic compound. It is an aromatic compound. So this type of conjugation is called as aromatic conjugation. Okay. And it also distinguishes between conjugated and non-conjugated systems. Some of the molecules are in conjugated and some of the molecules are not in conjugated. So we can easily distinguish whether what type of molecule is in conjugation, what type of molecules are not in conjugation. Such type of distinction also will be given by this UV visible spectroscopy. And one more important thing also it will give, that is whether our molecule is homoannular or heteroannular conjugated ions. What is meant by homoannular and heteroannular? See here. This is homoannular. This is homoannular. Homoannular means alternate. See here, double, single, double. This is in conjugation. This is in conjugation. But that conjugation is present in only one ring. Is only in one ring. That's why it is called as homoannular dienes. Cyclic diene. Homoannular. Within the same ring. See here. Within the same ring. But hetero means these conjugations. See here, double bond, single bond, double bond. So these two double bonds, alternating double bonds, are present in two different rings. They are present in two different rings. That's why it is called as heteroannular cyclic dienes. Heteroannular cyclic dienes. So there are two different types of annular cyclic dienes we have. One is homoannular and the second one is heteroannular. These two can be easily distinguished with the help of this UV visible spectroscopy. This data also will be given. Okay, see here, this example and this example, in which double, single, double, that means it is in conjugation. But see here, it is double, single, single and double, that means it is not in conjugation. But whereas if you observe this, it is in conjugation. 1,3 butadiene, it is in conjugation, but 1,4 pentadiene, it is not in conjugation. Okay, so we can easily distinguish whether our given organic molecule is in conjugation or not. That can be easily estimated or determined with the help of this UV visible spectroscopy. Got it? So now, if you observe this UV visible spectroscopy, it is also called as electronic spectroscopy. Why it is called as electronic spectroscopy? Because see here, it is ground level. In ground level, one electron will be there. If you are passing the light and if the electron is absorbed this light, automatically it will get excited. So the electronic excitations are possible. Electronic excitations are possible. That's why this spectroscopy is called as electronic spectroscopy. So electronic excitations are possible once the electrons are getting or absorbing some wavelength containing light. Okay, so that's why it is called as electronic spectroscopy. See, there are 4 different types of electronic transitions we have. By the absorption of light, the electrons will transit. Electrons will jump from ground level to excited level in 4 ways. That is sigma. Very important it is for mid examinations as well as for main examination. It is most important for us. How many types of electronic transitions we have with respect to visible spectroscopy? The same question will be there. Okay, sigma, sigma star, n to sigma star, pi to pi star, and n to pi star. 4 different type of transitions are possible. Sir, what are these transitions? What is sigma? What is n? What is pi? See here, just by observing this diagram, you can get a good knowledge about this electronic transitions. See here, in which I have taken the sigma bond at the last, that means at bottommost, and above which I have taken the pi, above which I have taken the non-bonding, after that pi star and sigma star. These two are anti-bonding and sigma and pi are bonding, and n means it is non-bonding. Just now I have mentioned that non-bonding means it is nothing but equals to a lone pair. Non-bonding means it is nothing but equals to a lone pair. Okay, so if you arrange, U means already in a molecule these particular levels have been arranged basing on the energy. See here, it is lowest energy, but it is highest energy. Okay, from the lowest energy orbital is bonding, that is sigma, of that pi, of that n, of that pi star, and finally sigma star. See here, if this electron is absorbed some amount of light, that electron will jumps from this sigma bonding to sigma star anti-bonding. Such type of transition is called as sigma to sigma star transition. So in sometimes what will happen, if you give much more amount of energy, by the electron will absorb much more amount of energy of light, then what will happen, the electron will immediately jump from the very lowest energy level bonding sigma to very highest energy level, that is anti-bonding sigma star. But in sometimes what will happen, the electron will jumps from this pi bonding to pi star anti-bonding. So such type of transition is called as pi to pi star transition. In sometimes the electron will jumps from non-bonding electron energy level to sigma star energy level, that is n to sigma star, that is n to sigma star transition. This is one type of electronic transition. And finally, in sometimes the electron can only jump from non-bonding to only pi star, non-bonding to only pi star. See here, at the bottom I have written the order of the energy levels of all these transitions. If you observe the sigma star, see here, very highest length it is. That means very lowest energy level to very highest energy level, the electron has been excited. That means the energy is very high for the excitement of the electron from sigma to sigma star. And the last one is n2 pi star. See here, the last one, it is n2 pi star. It requires very less amount of energy, then immediately it jumps only from n2 pi star, that's all. Okay, so the order is this: sigma to sigma star, after that n to sigma star, and pi to pi star, and finally n to pi star. This order also you have to keep in your mind. So these are the important electronic transitions which are possible for a different type of organic molecule. For a particular organic molecule, sigma star transitions are possible. If you take a particular organic molecule in which if you pass the light, the sigma star transitions may be possible. But in some of the organic molecules, n to pi star may be possible, or n to sigma star may be possible, or pi to pi star may also be possible. It depends on organic molecule. It depends on organic molecule. So if you change the organic molecule, the electronic excitations are also may be changed. Okay, so based on the excitations, the spectrum will comes. Based on the spectrum, you will get a knowledge about the organic molecule. That's all. This is the entire phenomena of UV visible spectroscopy. See here, if you observe the sigma star transitions, sigma star transition, for what type of organic molecules these type of electronic excitations are possible. This is most important thing. For what type of organic molecules sigma star transitions are possible. See here, saturated hydrocarbons, that means carbon is having only the sigma bonds. Carbon is only having the sigma bonds. Such type of organic molecules, in such type of organic molecules only the sigma star transitions are possible. Okay, let us see all the transitions, then we will come back again. Okay, if you observe the n to sigma star, n means non-bonding electrons, that means lone pairs. See here, this is a lone pair, this is a lone pair, this is a lone pair. So lone pair containing any atom from which it will be excited to sigma star. So these electrons will get excited from n energy level to sigma star energy level. Such type of transition is called as n to sigma star transition. Okay, so generally if you take the examples like saturated halides, that means if you take CH3Cl methyl chloride, C2H5Br ethyl bromide, it is a halide, it is a saturated one, so it is saturated halides. So these type of saturated halides, alcohols, why we need to choose these alcohols? Because alcohol is OH, this oxygen is having lone pairs. So if any organic molecule in which whether the substituent or whether the functional group is having any lone pairs, such type of molecules in which the n to sigma star transitions are possible. If you take ethers, bond O bond, it is called as ether, in which also the lone pairs are there and only the single bonds are there. So n to sigma star is, sigma means single bond, n means lone pair. Okay, sigma star, what about the previous one? Sigma star means single bond, only the single. See here, it is a single bond, these are all also single bonds. So single to single, sigma to sigma star. But n to pi star, n to sigma star means n means lone pairs, sigma star means single bond. So lone pair to single bond. If any organic molecule is having lone pair as well as with single bonds, in such type of molecules the n to sigma star transitions are possible. If you take aldehydes, if you take ketones, amines, etc. and etc. And if you observe this, pi to pi star, pi means pi bond, that molecule should contain, it must contain the pi bond, otherwise this type of transition is not possible. So for a molecule, it may be alkene or it may be alkyne. It may be alkene or it may be alkyne. Alkene means carbon-carbon double bond. Alkyne means carbon-carbon triple bond. So if you take any of these type of molecules, whether alkenes or alkynes, these type of molecules, in these type of molecules, what type of transition is possible? Pi to pi star, because that is containing only pi bonds. So pi to pi star transition is possible. Okay. In some of the carbonyl compounds and cyanides as well as azo, N double bond N is called as azo group. This is an azo group. In azo groups, in cyanides, in carbonyl compounds, alkenes and alkenes, in these type of molecules, what type of transition is possible? Pi to pi star transition is possible. Okay. And the last transition is N to pi star transition. N to pi star transition. So in what type of molecules N to pi star transition is possible? Just simply by observing this diagram you can easily find out. N means lone pair should be present, non-bonding electrons. That means lone pair should be present. This is one of them. And pi star, pi means double or triple bonds. So if the organic molecule is containing minimum one lone pair and minimum one double or triple bond, that means multiple bonds, then such type of molecules are participated in N to pi star transitions, in which the electrons will get excited from N level to pi star level. I think I am clear. Is it right or not? Got it or not? Anyone? So 4 different types of transitions we have: sigma sigma star transition, N to sigma star transition, pi to pi star transition, and N to pi star transition. Right? See here. In sigma sigma star transition, this is the notation. If you want to write the sigma sigma star, this is the notation for us. This is alkane. It is alkane. In this alkane, one electron in the sigma bond will get excited to sigma star. So that will be notated like this. Okay? Propane, methane, etc. and etc. All alkanes in which the sigma sigma star transition only will be possible. Okay, see here, if you observe the wavelength category, this methane and propane has been absorbed the wavelength at nearly 150 nanometers. So at 150 nanometers wavelength, what will happen? It is highest amount of energy in which the sigma sigma star transition is possible, because it is having highest amount of gap compared with all the remaining 3 electronic transitions. So sigma electron will transit to sigma star energy level by absorbing this 150 nanometers. Wavelength is less, but the energy is very high. And in this case, N to sigma star. See here, this is the notation. This is the notation. How you will notate it? This is N to sigma star. See here. This is N to sigma star. This is the notation of N to sigma star transition. Generally, if you take the water can absorb the light at 167 nanometers. Here the wavelength is somewhat high compared with the previous one. In the previous case, you have taken 150 nanometers only, but here it is 167. That means wavelength is high. What about the energy? Energy difference is very less. For methyl alcohol, again the wavelength is much more, 174 nanometers. For methyl chloride, it is 169. Methyl chloride, it is 169. But for methyl hydride, it is 258. So the wavelength has been increased. That means energy has been reduced due to this formula. E is equal to hc by lambda. Once you are increasing the wavelength, energy will be reduced. Okay. So this type of transition is called as N to sigma star transition. Okay. In this N to sigma star, compulsory the organic molecule should contain minimum one lone pair and minimum one single bond. Coming to the third one, pi to pi star transition. Pi to pi star. That means this type of transition can be possible only when the organic molecule is containing pi bonds. That means alkenes if you take, alkynes if you take, these type of molecules only participates the pi to pi star transition. Okay. See, this is a pi bond. This is a pi bond. It is a sigma bond, of course. It is a sigma bond. It is a pi bond. So this electron, this pi bond will get excited. This pi bond will get excited to pi star energy level. That's why it is called as pi to pi star transition. Generally, unconjugated alkenes. Already I have given the complete details about the conjugation and unconjugation. So if you take any unconjugate alkenes, they are absorbed the light in between 170 to 190. So it is very high again. It is once very high means the energy level is very less. Wavelength is high means energy level is very less. In the same, if you take any carbonyl compounds, they are absorb the light around 180 nanometers. Again, the wavelength is high, so energy level is less. Coming to the last one, that is N to pi star transition. N means non-bonding, that means lone pairs. So this type of transition is possible when the organic molecule is having the lone pair along with pi star. Pi star means compulsory this should have one pi bond. So one lone pair should be there, one pi bond should also be there. Then only the N to pi star transition is possible. Got it? So what type of molecules will undergoes these N to pi star transitions? Generally, carbonyl compounds will have this N to pi star transition. If you take the wavelength, 290 nanometers of wavelength has been absorbed by the aldehydes. That means CHO. Aldehydes will absorb 290 nanometers. That means it is also very high. 290 means it is very high. That means the energy level is very less. That's why the order is looking like this. N to pi star. N to sigma star it is, pi to pi star, N to pi star, and the highest energy level is sigma to sigma star. That's all. I think I am clear about this. Is it right? Got it or not?
Yes, sir.
So these are all about only UV visible spectroscopy. These are all about only UV visible spectroscopy. It is called as electronic spectroscopy, also called as electronic spectroscopy. So in the next class we will discuss about the IR as well as NMR spectroscopy. So tomorrow as well as day after tomorrow we will have the classes. Tomorrow and day after tomorrow we will close this entire spectroscopy concept. Got it? Any doubts? If you have any doubt without getting any hesitation, please ask me. No problem. Right. Thank you. Thank you very much. So I will send the notes to you through the groups. Please go through it. And if you have any doubt, please ask me. Okay. Thank you very much. Thank you. All of you.
Yes.
Yeah.
అయిపోయిందా నాన్న బోర్డు తీస్తాను
ఫోన్ చేశారు
ఏంటంటే
రేపు పొద్దున్న వస్తా అన్నాడు 6:37 మధ్యలోనే డాక్యుమెంట్స్ తీసుకోవడానికి
నాన్న
కేవీఆర్ వర్క్ 4:30 నుంచి బాగుతాడు అన్నాడు ఆయన.
4:30
మరేంటి 3 లీగల్ ఒపీనియన్లు ఉన్నాయి. నేను ఈరోజు నైట్ వద్దనిసాను. నైట్ చేయలేను సార్ మార్నింగ్ అంటే అయితే మరి 3 ఉన్నాయి నాయన మరి ఎలాగవుతుంది ఎన్ని గంటలు కూర్చుంటాం ఏంటి అని అన్నారు. 6 కూర్చుందాం అన్నాను. అవ్వదు నాయన అట్లీస్ట్ 4:30 అయినా మనం కూర్చోవాలి. 3 లీగల్ ఒపీనియన్లు కదా.
నాన్న బోర్డు తీస్తాను